Well, first I will introduce myself. I am Thomas Klein Langenhorst, and I'm a developer here at Iconica. For about 2 years I work here now. I'm mostly a Svelte developer, but in my free time I like to spend my time discovering new technologies and also web technologies. And that's how I came about Svelte. Okay. Yeah, first the agenda. First, I'm going to tell a little bit about the history of the web and some of the techniques used, and then I will roll into how Svelte is relevant in this. Then I'm going to talk about some basics, reactivity in Svelte, props, templating, events, bindings, a little bit of life cycles in Svelte, state management, animations, advanced styling, component composition in Svelte, special elements, and the modules. So, from the beginning, JavaScript was made in 1995 by Ben Ike as like a first scripting language for the web to use in back then it was Netscape to make websites a little bit more dynamic. And later, in 1997, they first made ECMAScript, the first standard for JavaScript, to give it the same standards for everyone to use, because of for example, take 2000 when Internet Explorer became popular, it got 90% market share, and it kind of went and did things on its own. We all know how that fragmented the web and everything you have to implement. Luckily, it's now dead from this year, so you don't have to deal with that anymore. A little bit later, jQuery came around, also an important step in web technology to make JavaScript a little bit easier to use, also to implement in different browsers. So mostly that it's not really that relevant anymore, but it has an important place. So then later in 2008, Google released Google Chrome built on top of Chromium with the V8 engine, and that really changed how JavaScript was used. From that point on, it could be JIT compiled, so instead of being in interpreted language. And about a year later, Ryan Dahl made Node.js with the V8 engine, and that way we could use JavaScript on the server side to make backends, or nowadays we can even pre-render JavaScript basically on server side. He later made Dino with some changes, also a runtime, but with some improvements like security and the way packages are handled. If you really want to know more about that, you can watch this video, 10 things I regret about Node.js. It's a really interesting video, but okay. And later, also this year, yeah, also later this year, ES5 came around, one of the first big major updates in JavaScript with things like stack mode, array functions, JSON objects, all that, and also coffee script came around, and that was like one of the first languages, so to say, that could transpile to JavaScript. So that's a really important part for later. And also later in 2010, Angular came around, and that also changed how we could render components in the DOM. I'm going to talk a little bit more about that later. But yeah, that really changed how we could declaratively change the DOM in the web. And well, 2015, a little bit later, E6 was released, one of the biggest major updates to JavaScript with things like classes, asynchronous code, and things like arrow functions, map and set. So that was also a really big change to JavaScript, and also, like I said earlier, we could do more with vanilla JavaScript, so we don't need things like jQuery anymore. Well, also this year TypeScript released, so to keep it simple, it is basically strongly typed JavaScript. That was also a major thing on the web, because, well, most of the JavaScript software is basically built with TypeScript nowadays. And React also became popular, and that was also yeah, a really big framework that really changed the web with the virtual DOM, made it a lot easier to manipulate and change the DOM in a declarative, simple way. And also, well, modular bundles became a lot more of a thing. So we could basically bundle together all JavaScript, CSS, all that good stuff, and packages together and ship to the web, because everything became so big and bloated and got really out of hand easily. Yeah, you got things like, well, maybe most of people know Webpack, or Gulp, and later Feed in 2021. Well, that's Feed is now becoming really popular. And well, the last major thing is WebAssembly in 2017, and that was a way to compile languages like C, C++, Rust, or Go, anything like that to the web, and you could even use it with JavaScript to run your applications in the web. And well, the rest is basically history, like things like, for example, we use Flutter. Later, Flutter became able to run in the web, all that sort of thing. So, but one major thing I want to talk about is, well, basically DOM manipulation. So, like I said earlier, JavaScript is used to mostly manipulate the DOM, and the DOM is basically this object model of well, tags in a tree. So you have your document with HTML, head, title, and everything underneath. And well, what basic JavaScript looks like, plain old JavaScript, you could really easily manipulate everything in the DOM. So you could, for example, say here, I can say like document create element. I can give it an ID, some inner HTML, and then I can append it to the body by saying append child to the body. Basic stuff, and you can get really big with that. It can be a little bit clunky for really big applications. Also, an option is like string based by, I don't know, concatenating all of your tags in like a string and then render it out. It's not really recommended. It gets really messy. Well, you can use it on smaller scales, like even Svelte uses this a little bit under the hood, and things like with HTML does this sort of thing. But no, you can sometimes see this in old legacy code, but it's not recommended. Well, and we are coming back to jQuery now. Like I said, it became a little bit easier with these special functions. You can just say like a document ready, and then like in this example, I grab a button and just say click click event, and then I can, for example, hide the paragraph element. So it gets really simple, but also, well, back then it was really useful to use. But nowadays you don't really need it. Well, then you got the incremental DOM. This is what Angular uses under the hood to update the DOM. And what it basically does is it creates a set of instructions, and then like to create like parts of the DOM tree and then render them out. So like in this example, you can really just, for example, here add something to your DOM tree, delete, and all these well predefined functions, so to say. Yeah, it still needs a runtime to do to make it work. So that is like a bit of a thing, but it doesn't cost very much memory to do. But then you later on, and this is what React pioneered, and later also frameworks like Vue use. And that's the virtual DOM. And what the virtual DOM basically does is it creates a new virtual DOM tree in the memory, and then like basically compares the old DOM to the new DOM, and then renders it out. And so it's really easy to use actually, but it costs a lot more memory. And well, if you take React, for example, you can write your components like this with, well, in this example, it uses JSX. It's basically like an XML, or it looks like HTML, but it isn't really HTML. It's a sort of XML syntax. Well, you can also use, you can also write your React components basically with JavaScript. So in this, you can create an element and give it some properties, some objects. And this is basically what React renders out with JSX. So it basically creates this and then stores it in memory and then compares them every time. Okay. But there's a little problem with this. Although the virtual DOM is very easy, it's basically overhead that you're creating. So let me clarify this. So let's go back a bit to 2013. React was in its very early stages, closing into a 1.0 release. And one of the former React team members, Pete Hunt, talked about React and the virtual DOM and how it's used. And he basically said like that the virtual DOM is really fast just because the normal DOM is slow. Now, well, he basically went like, yeah, it just tends to drop frames, and it's just not, yeah, not very good to do it manually. But why is that not really true? Like, somebody know why it could be that the virtual DOM is not?
Well, it sounds like it's fast compared to the DOM. That doesn't mean the virtual DOM is fast. Right?
Well, yeah, you kind of do. The DOM is very fast. The virtual DOM is fast, but you can't really. You always use the DOM API that JavaScript uses, so you can't really pass around that. You can't get past that. You always need to define those functions to render them out, basically. It's always in addition to what the real DOM is doing. And well, back then there were a lot more less efficient frameworks to go around. And what you're basically saying is basically an alternative that nobody does is like render my whole application in the main document. Like it's really weird actually. Well, he later clarified like you could, if you're smart about it, you could outperform or make something that outperforms React, but to keep it short, but well, that doesn't really, that didn't really stuck with some people. So so to go in a little bit more detail, like the virtual DOM, is it slow? No, it's not slow. It's very fast, but it has certain caveats I would like to talk about. Like one of the caveats is the original promise of React was you could re-render your entire app with every single state change without worrying about performance. And well, in the long term, that didn't really work out. Like, and the React team knows this. People who know React, they maybe know like component functions like component did mount, should component update, should component did update, all that sort of thing. Now, yeah, nowadays it's mostly React hooks with functions. So you have things like use effect, use reducer, use callback, use memo, all that sort of thing, to basically give the developer the power to optimize their application. So to go in a little bit more detail, like take for example this simple React application before optimizing. Like what the virtual DOM basically does is every time it compares every single state change to what has happened, and it does from the very top to the bottom, or like from the component that gets changed, renders everything down. Like in this example, I could, with every keystroke, okay. Well, in this example, it should actually oh, yeah, it's this one. yeah, what I want to show is basically in this example, you can really see every single keystroke that I do in here. Everything is rerendered, even this little child component. So yeah, and one of the simple things you can do is basically, well, in this example, really simple, you can move the state to different components, and then like, well, it doesn't re-render the child component every time. Well, really simple stuff. But to go in a little bit more detail and some different hooks, so to say. Well, in this example, you have, for example, you have this, well, still this, the console driver. Well, you still have this little input foot, like with the previous example, every keystroke, the child components get re-rendered. Look at increment, well, and then it still re-renders. But well, let's take this example, and then we have a little bit more hooks like use memo and use callback. So what I'm using is a use callback hook to basically set a new in this a number, so it increments a number, and well, the most important part here is that it keeps track of this little number from the use state. Well, I also have this use memo hook to return a function still with the count value, and well, basically saying like remember this value unless it changes, and then re-render my components. So then a little bit on here, so I can still, like with the previous example, this doesn't re-render my child. If I do this increment, well, it's a little bit of a delay made here with a for loop, but yeah, you can still increment. You can still increment here. So yeah, there's all these special kind of hooks and things to yeah, give you the power to optimize your components. But why would you do that beforehand? Like, well, and one of the other things. Oh. Well, and one of the other things is just DOM diffing is it ain't free. Like it costs a lot of memory and efficiency to render these props out every time. So to go in a little bit more detail, like I said, what filter DOM does is compares the old DOM to the new DOM. But what it basically does is every time something changes, it goes to everything. Like, is it diff change? Is it a crash? Is it not a crash? The paragraph component, is that changed? The list, is that changed? Well, and also like this, things like, for example, you wanna render out a list. Well, in this example, you can just use plain old JavaScript to map them out. But if something changes here, everything gets re-rendered every time. So, and also if something maybe above it changes, gets re-rendered, unless you use like hooks. And that's also like really weird, actually. It's not efficient. So, well, it's actually important to remember, like, the virtual DOM isn't a feature, but it's certainly a means to an end. And well, in terms of performance, it's generally good enough. But basically, what people wanted with Svelte is basically proof that there is a better way to do this than with the virtual DOM. So you may be asking also what's up with Svelte right now. Well, what Svelte basically is a declarative framework that turns your declarative code that you write into plain vanilla JavaScript at a build time. So it's basically comparable with a compiler. So so if you wanna get in a little bit more detail. That's my mouse now. So to look at it a bit more detailed, like this is what basically Svelte compiles. So if you look a little bit at the internals, like you can see a little bit, like here this create fragment function. Well, it has a value, and here you can see like the h1. Well, this h1 gets gets put into an element, and then like Svelte can like see that it has that is coupled to in this case this HTML component with a name, so it just renders that out. And well, a little bit down the line, you can see like everything gets turned into like a class, a basic JavaScript class with some additional functionality. So this is basically what Svelte is. It's a compiler. So to go into the details. All right. A basic Svelte component is basically a script tag, your templating, and some styling. Well, the basics, you can just add values here, functions, everything. And the templating, well, you can just use about everything in here. So it's basically JavaScript. So in this case, you can, for example, say like too uppercase or really too fancy. You can even use dynamic attributes for everything, for all tags. So in this example, you can say like the SRC, you can just short it to SRC, and that Svelte knows what to do with it. But about the templating, I'll go in that in a little bit. You can also add like CSS directly to your component. So you can just use a style tag like most templates. It's even like scoped by default, so everything you write in your component is just scoped to that component and doesn't get mixed with everything else. Unless you give it a global, then it just gets global. Well, like all the frameworks, you can also import different nest components of Svelte components and nest them in your templating. Like in this example, nested components you can just use like this, or even shortened with here the backslash also works. Yeah, templating. Svelte has these special block templates you can use to like earlier you can put your variables in there, but also you have, for example, things like this with the HTML tag. So well, this one just renders HTML out. The only thing to note here is that it doesn't get sanitized, so you have to escape it for yourself. That's the only thing, but yeah, it can just, in this example, it can just render HTML, but also I'll go in a little bit more detail later with the blog, with the tags. Okay, reactivity. Well, one of the major things in Svelte you can do is the reactivity system. It's actually very easy to use. Like you only have to use the let keyword to like set a value, and it's reactive. Just like that, no hooks, nothing else. You can even use like functions. For example, in this, you can get a button, you can give it an on click, and then it just updates this value and everything gets re-rendered. And then you can also use it further in your templates to give it some, make it a little bit more dynamic. You've also special declarations, like for example, this one. Does somebody know what this means? The little dollar sign on?
I think it's a shorthand to execute a function or something. Like if you access it, it will do the thing that's behind the equal sign.
Yeah, you're close, but well, this is basically a valid HTML. It's a labeled statement, and Svelte uses this a lot. Like what it basically does is basically every time, like in this example, the count gets updated, this one gets updated. So you can just make these dynamic variables that change every time. So in this case, you can do the count by 2 and you get a double value, and you can just reflect that. Like in the previous examples, you can just display it in your template. But it doesn't, it isn't limited to just keep values, keep track of values. You can also give blocks, or use blocks in it. Like in this example, I can use an if statement to see if the value does it get higher than 10. You can even just execute different blocks of code in it. So it's very versatile in that regard. Props. Well, like in all the major frameworks, all your components have properties that they can use. You can pass values to different components. The only thing you have to do in Svelte is just give it an export. So if you say in this example, export that answer, and then you can just, right here, you can give it a prop. In this case of a number, you can even give like default values. So yeah, it's really easy to just pass things down to child components. You can even make it easy for yourself, like you can even spread your props. Like in this example, I have an object with a few variables like name, version. And if you do things like this, like with this component, you can just, well, you have a lot of properties you have to give. You can just use the spread syntax of JavaScript to make it a little bit more easy to use and a little bit cleaner. That's also like one of the major things of Svelte. it tries to keep everything limited. You don't have to write a lot of boilerplate code and keep everything clean and small. Templating. Well, like you saw earlier, you have a pretty dynamic templating syntax to use in Svelte. So, for example, you can use these special blocks. For example, you can use the special if block to make simple if statements. You can also if else, just if, and then those else. You can even do like else if. Gets really dynamic and really easy. You also have like each block for loops, so you don't have to like use for each of map or map like you normally would. So like here we have an object. I can say for in this I have an array of cats with objects in them. I can even spread them, so I can only use the values that I want to use. You can even give them an optional index. Yeah. You can even use key to each block. So in this example, we have another list of objects with IDs and names. And like in here, you can just add like a key to it with braces. So in this example, I use the ID as the key. Because what sometimes happens is if you render things to the block and you manipulate your, in this example, your array, then Svelte will update it and then removes the last node in your DOM. So you can use the key to say to Svelte, like, this is the property I want to remove from the DOM, so it can easily keep track of everything. You can even use the await block to await promises in your templating. Like in this example, I can use the await if nothing is if there is no value, I can just put the tag here. If there is something, in this case a number, I can just say the number is number. You can add a catch block if something goes wrong. You can even shorten that a little bit if you have a promise that resolves immediately or can't fail. So you can just say await then in one line. So simple things like that. There's even a key block. This, if like the value changes here, this component gets reinitialized every time this value changes. Little bit later, you can see a little bit more detail when this is useful, but it can be useful if you want to update something every time a value changes. Well, like earlier, the HTML block, like I said, you have to escape it first. Because Svelte just renders it out, it doesn't do sanitizing for you. You even have a const block for in like each blocks or ifs. You can just add a constant to it. And the debug block to console log objects to console. Events. Well, Svelte also has a really powerful event system to make it really easy to use events like you normally would in the DOM. normally you would write special listeners for that. But in Svelte you have really a lot of built-in events. Like, for example, in this case, on mouse move, I can couple my function to that, and I can just say, in this example, the x is bound to kind x, and you can just, if I over here, just shows the coordinates of my mouse. But there's a lot of built-in ones. You can even use it inline if you want to. Svelte doesn't have any performance penalties on using it like this. Svelte has even has modifiers to change the behavior of your events. So like in this example, I can add an on-click for just once. So this one only gets triggered once in your component. Well, a list of all the modifiers, like most people here probably know the event default. Things like passive. Well, Svelte does this one mostly for you. Once, like I said, self. And there's a lot of these you can use. You can even create events for yourself. So you can just use the create event dispatcher to create events for your components. Like in this example, I create a dispatch with message and text hello. So I can just say, in this example, on message, the name of the dispatch, and I can just add my function to it, and then I can use the event to get the text and then render it out. You can even forward these events. So you can say, like in this example, I can add my function to this component, and then I can pass it around to the inner component, and then this component handles, like in the previous example, the dispatch. But event forwarding also works for DOM events, so the on-click, the basic things like that. Bindings. Svelte also adds a really easy system for binding values to like input tags, like one of the major things you will probably be doing. Like in this example, you can just use bind value to bind, in this case, the value of name to this input field. And it gets rendered out immediately right here. You can kind of do the same thing with, for example, numeric bindings for like numbers and ranges. Also, one of the nicer thing here is because everything is like a string in the DOM, normally you would have to cast it, but with Svelte you don't have to do it, so you can just bind a number to it and it just works. So that's one of the easier things. Checkboxes, bind checks, and click a boolean. You can add a boolean to it. Even like radio buttons, so you can add a group to it and a value, and then and even like checkboxes. So like in this example, I have an array, I can use each block, and then bind the value to this input. So you can get really creative with this. Well, select multiple, and you can just add the multiple. modify to it. You can even create content editable bindings. So if you add content editable to it with a bind of, in this example, in HTML, you can edit, in this example, some HTML, so it gets really easy. You even have some special bindings, for example, for media bindings. So like in this example, I have a video tag. I can add the common ones to it, like on mouse move, on touch move, mouse down, mouse up. But you also have special bindings like current time, duration, or pause. Yeah, you can do a lot of modifications with this. Also, one special binding on every tag is dimension. So you can, for example, like here, you have a kind width, kind height, offset width, and offset height, and you can just bind it to values. So in this example, you can bind it to like two different values and just change how large your tag. Yeah. Oh, what is it?
Are you aware of the time? Because it's
Oh.
quarter past.
It's because we start 5 minutes later. I think we have to round it up because otherwise we don't have a short break.
Mm.
And we have a second session after this, so.
Oké.
Because of time.
Eens even kijken. Yeah, I can do a little bit. Well, Svelte also has, like most major components, has life cycles. So you have like on mount, on destroy, before update and after update. And you also have a tick, so you can use that to await a micro test, to wait for Svelte to update. Even kijken. Well, context API, well, it's really easy. Just like, for example, in React, you can set context and pass it down to the children. So you can give it a key, some value, and you can just grab it out of the context. Yeah, you even have wider stores, like for better state management. Like for example, Wireable, that you can subscribe to and then update the values. You can even add auto subscription with a $sign. Well, readable store is kind of the same.
You have to wrap it up.
Yeah.
Otherwise, there's no.
Nee. I'm gonna keep it at that. So that's what best is.
Yes, the next meetup you can talk about part 2 of this topic. So there's way more stuff, perhaps another 45 minutes of content. So it's very possible that in the next meetup you can talk again about the topics you didn't cover today. Thank you very much.
Thank you.